Thank you very much for the introduction, Simon. Welcome to our talk about bringing NLP models to production. And I know it has been a long conference. I'm very proud of you that you're here despite the social event yesterday, despite lunch break and probably information overload. We try to not overload you after lunch break, so please stay with us, stay awake, and I'm looking forward to the talk. So we've brought to you some of our real-life NLP use cases where we faced some obstacles, some issues, also due to requirements change. And this topic will focus on how we dealt with these obstacles, which ways we used to overcome those. That's why we will first start with a journey to NLP ops. I don't know if this is even a term. If not, I invented it yesterday. So first the journey, then we have our two use cases shortly described, and then we have a short checklist you can take away and use for probably every other machine learning project, NLP projects, of course, as well. So let us introduce ourselves first. So I'm Larissa. I'm a senior data scientist at Savanta AG. If you want to chat with me afterwards, you can also talk to me about science fiction or playing RoundNet. I will also be happy to talk about that.
Yeah, hi, my name is Jonathan. I'm also working at Savanta now since 1 year. Before that, I studied physics. And if you are interested in the sports called Jugger, or if you want to talk about the board game Terraforming Mars, then also I'm the go-to guy. Yeah.
Some known people. All right, so let's start first with maybe some boring topic. So what does our company do? But this is important maybe to understand some deployment decisions we took. So we're working at Savanta, which is basically a user experience company. So we started to do good user experience for SAP, and then developed other experience fields around it, such as chatbots, AI assistants, and also machine learning and artificial intelligence. And therefore, a short disclaimer. So we are talking maybe about SAP solutions, but the implications of those deployment decisions, you could also draw them on other deployment platforms, as they are also open source. So this is not exclusively SAP related. And even though we are an SAP partner, we're not paid for this talk. So these are our experiences, and we want to give them to you, so maybe you can do maybe better decisions or other decisions than we did. And yes, this is not necessarily best practices, but we want to give you our experiences so you can learn from that. So why we wanted to do this talk? When I started working at Savanta back in 2018, the latest or the hottest topic were BERT models and ELMO and stuff. So this was really in the beginning. And as you can see, in NLP, the development of model sizes was really quick. I mean, every some months there is a new model with new cool features, and this is why we should talk or think about model deployment in NLP especially. I mean, this is a case for other machine learning models as well, but in NLP the models are getting real big really quickly. So this is an important topic. And even though I don't want to deploy, for example, ChatGPT by myself, but even like for smaller applications, NLP models can get really big. And this can lead to problems at the deployment in the end. So our goal is to make you aware of the following. During your NLP journey, which roughly consists of those points, you will make a lot of decisions that will impact the deployment options later. So during our talk, we will have a checklist oriented on this journey to NLP ops. And with this checklist, you can have a look if you considered everything that you need to decide your deployment. So when you start with a use case, you're probably thinking about, okay, what are we talking about? What's the problem I want to solve? Will it be a service? Will it be a testing front end? Will it be a multi-language model or everything together? So this can have implications. Later on, you will do maybe brainstorming. What tools do I have at hand? Which restrictions do I have? Do I have certain deployment limitations? What are my possibilities in general? And as next step, you will maybe gather requirements. Do I need a regular retraining? How fast does my model need to respond? Do I need to fit in some company standards, or do I have to fit in some existing company infrastructure? Then as the next step, you will get some data. So how does your data look like? Do you need data augmentation? Do you need certain preprocessing steps that you also need to transfer, also need to do later during inference? And as last step, you will train a model. But what kind of model will it be? Will it be like a plain NLP model using TF-IDF? Will it be a Hugging Face transformer model? Can you apply some pruning at the end? So these are questions. And then you can start with deployment, right? Yes, but that's part of the truth. But because during those questions and during those answers that you gave yourself to those questions, you already decided part of your decision about the deployment, because all those decisions influence your deployment options. And this checklist, it's not complete, but it might help you to ask the right questions in your journey. I will not go through each and every point in detail. You will see that in the use cases, and we've also added an explanation about those checklists in the appendix, so you can later on download the slides and have a look at it. And important is, there is no rule like, if this, then that. So, I don't know, if I use TF-IDF, I can deploy everywhere. So maybe that could be true, I don't know, but you could only collect pros and cons. You will always have to balance, and there will never be a clear decision, okay, this is what I have to use. Take this more as a guideline. So let's start with the first use case. I called it here product search, and this is exactly what it does. It is a feature for a chatbot interface where you can, for example, the user can type in, I want to buy vegan pizza. So through this chat interface, we have a wrapper service, and our NLP service is called to extract the important information we want to have from the sentence. In this case, vegan as a property and pizza as a product. The property describing the product. From the NLP service, we reply this, and then we search in the database if we have vegan pizzas in our database, and then we reply with the options. So this is roughly the use case. How we started to deploy this or to work on this, we had a spacey model. It was one language. It was German. It worked really well. And we deployed it on Cloud Foundry. I don't know how many of you are familiar with Cloud Foundry. It's an open source cloud application platform. Maybe similar to Kubernetes, but it supports you a little bit more on the infrastructure side than, for example, standard Kubernetes. And you can upload. Also, they are not called images, they are called, droplets are starting on that platform, which you can build with build packs, which are all available for other languages. And in this case, Cloud Foundry was self-hosted by the customer we worked for. So this was, the solution we went. The drawbacks here, Cloud Foundry comes with an upload limitation of 1 GB, which includes all files, also the model in this case, and all dependencies, which will be a problem. You will see in a minute. And we had like 4 GB of disk space limitation, which was also kind of critical later on. So the model worked. It was really nice for the customer. They really liked it, and they said, okay, let's do this in 10 other languages. Let's do this even better because we have no training data for you. Okay, so maybe Spacey is not an option anymore because we cannot fine-tune our models in this extent we needed it. So we switched to a transformer model, where the fine-tuning it was a little bit better to do, and we had a wider option of language choices because the customer was really creative about which languages they wanted to use, Hungarian one of them. So the size of dependencies really exploded. We had to rely on TensorFlow, and this just exploded our 1 gigabyte upload limit. And also the running perspective changed, so we grew from a POC stage to a running in productive for several years stage. So Cloud Foundry was not an option for us anymore. We had the luck that the customer also had an Azure stack at hand, so we switched to container instances, which is maybe a smaller version, you could say, like a Kubernetes cluster. It's just singular containers running independent of each other, so we could deploy our services there, and we deployed single services for single languages, so all of them running in parallel in 2 stages, dev and prod. The advantages, we can really easy start new container instances. We don't have to think about, okay, do they have to be managed in a cluster? This gets complicated. So this was really easy. And the deployment was also a little bit easier because, Docker is a little bit more familiar for us than Cloud Foundry, which is also easy but not as familiar for us. The drawbacks are you need somehow to build your Docker images. You need an infrastructure around it to host your images, maybe in a registry. You have to have maybe a CI/CD pipeline. So this overhead we had then additionally to the POC solution. So this was the first use case where we had problems due to the model size. Jonathan will now talk about a second use case where we faced similar issues but resolved them in a different way.
Yeah, thanks, Larissa. The second use case is now not about named entity recognition, but it's all about text classification. In this case, we already had an existing applications where users can analyze different events, and now a new requirement was that these events should be classified into one of 2 categories based on text information. So in this example, there would be an event with a text called that reads "no error was detected with the device," which then should be classified as being not relevant for this analysis, and maybe a different text in German that would read the sensor cable is broken, which would indicate that it's actually a relevant event. The users would rely on these classifications, but it's not so much that they actually requested them on demand when they were listing events. It's rather that in a nightly schedule, the wrapper service would call the model, look for new texts in the database, do these predictions, write them back to the database, and then the user can just look at them when doing their analysis. You can already see in this use case we started with 2 languages, German and English, and we were building one pipeline for each language based on just a simple plain NLP model, how we called it, which in this case means that we used a TF-IDF vectorizer, then followed by a classifier to do the job, which also worked really great for these languages that we had at hand. In terms of the dependencies, that also means we are quite small. It's like around 300 megabytes, so we are using scikit-learn and pandas. But this is no problem to, again, deploy it on Cloud Foundry. It's very important in this case, we had this already existing application, and now the machine learning model was an add-on and a new feature to this application. And this application was already running on a Cloud Foundry instance. This time it's hosted on the so-called SAP Business Technology Platform, which is just a cloud platform provided by SAP where businesses can develop and also deploy applications. And yeah, they offer a lot of additional services like database management and, for example, also a Cloud Foundry runtime where you can deploy applications. Yeah, and as the main application was running on Cloud Foundry, it was the choice was obvious to try at least and deploy the model there as well, so that we have an easy communication between the application and the model itself. The configuration on the business technology platform is a little bit similar or a little bit different. Now this upload limit is 1.5 gigabytes, but as I said, with this 300 megabytes of dependencies, that's not a problem for us. And also the disk space and memory allocation that you can use for single instances that are running on Cloud Foundry doesn't pose a problem for this kind of small model that we were deploying in this case. And the story is similar to the first use case. The customer was quite happy with the model, so of course we should extend it, in this case to all languages that these events can occur in, which are more than 20 for this use case. And of course, we don't have sufficient training data in all of these languages. So the option of just building a pipeline per language that we can deploy is not really an option. Again, instead, we use the transformer model from Hugging Face, specifically the Distilbert multilingual model that was able to cover all the languages we needed. We use specifically the TensorFlow implementation for the training, which also means that our dependencies get quite large. Similar to the first use case, you can already imagine that this will lead to some problems with the Cloud Foundry environment as it was before. So the preferred solution that you could imagine for such a larger model would be the fact to use like a dedicated AI runtime where you maybe also have GPU resources available that can scale according to the requests that you send to your model. And in case of the business technology platform, there is such a service available. It's called the SAP AI Core. So quite nice. But for our specific use case with this customer, we didn't have this available. So again, we needed to make do with what we had, meaning trying to somehow fit this now large model still on this Cloud Foundry instance and Cloud Foundry runtime. And as you see, the two major limitations are this app size during upload. With our dependencies, we break it. With the model size, we break it. So we somehow have to get around that. And let me just quickly explain our workarounds. For one, you can just save your model in an external blob storage and then just later on download it to the application. So there's no need to push it with the application code itself. Just have it saved in an external storage. And for the other fact that the model, that the dependencies are too large, we opted to use ONNX, which stands for Open Neural Network Exchange, and it defines a format how you can save your machine learning models in a framework-independent way. So by saving our model from the TensorFlow implementation of the neural network to ONNX, we can just get rid of this complete dependency, and then later on during inference, we just need the ONNX runtime package, which is much smaller as a dependency. In case if you want to learn more about ONNX, I think there was a talk on Monday, and they really went into detail about ONNX, also how to explaining how you can convert your own models or transformations to ONNX. So with these two changes, the app size limit was not a problem anymore. We could just upload our application that was hosting the model. But the second thing, of course, is that transformer models tend to like to use a lot of memory during predictions. And as I said before, on Cloud Foundry, with this 8 gigabytes limitation to only also CPU memory, this can lead to problems if you try to do large batch classifications. So in our case, we just limited how much the model can predict at the same time. This, of course, leads to larger response times of your model. But as we had these mainly scheduled scans that run overnight, this was not a concern for us, because if it's just running overnight, it doesn't make a difference if it's 15 minutes or an hour, at least for this specific application. So this concludes then our second use case. In this case, the changing requirements didn't lead us to a different deployment option or different deployment infrastructure. We rather implemented some workarounds to make do with the infrastructure that we already had. And now to conclude all of this and what we try to convey you as a message of this talk, when you develop a model, you always should think about your goal with the model from the beginning, like how will you later on serve the model and what requirements does this bring with you. And we developed this kind of checklist, the NLP Ops checklist, that you can use as a guideline, which defines some different topics that you can think about. And if you clarify all your options and restrictions regarding these different checklist items, this can guide you to the different deployment options that you will have available for yourself. We just covered the two in these use cases, but of course there are many more providers of cloud infrastructure that each come with their different advantages and disadvantages for some of these checklist items. And you just have a look around what's available there. It's also important, make yourself familiar with the condensing mechanisms that work for your model. So before saying, well, I have this new model, so now I have to change all my infrastructure, maybe have a look, can you simplify your model or condense it a little bit to make work with what you have? So for example, in the second use case, we used the transformer model from Hugging Face, but we already used the Distilbert version, which is just a smaller version of the bird language models. So maybe there's also an option that you just can make your model itself smaller. And again, as a last point, take all of this as a guideline because there is no true answer. The main thing that we want to tell you is that have a look at all these restrictions and think about them also during your model development, because decisions that you make during development of the model itself can also lead to or restrict yourself in the choice of deployment options that you have available. And with that, we want to thank you all for your attention. We hope you learned something or at least found it somewhat entertaining. And if you have any questions, we are happy to answer them.
Thank you so much for what I found was a very, very interesting talk. And I seem to be not the only person because there are quite some questions for you. Nice. Just a gentle reminder, you can vote on these questions. I only have one vote here and 5 questions. Use the opportunity you have. Question number 1 would be, how and where do you train the models and where did your data reside?
Mm-hmm.
So this is, I think, different for both use cases. In my use case, we train, so we experiment locally, and then we have our own machine learning server where we train and share models and data. So it's an internal self-hosted server which we can use to train the models.
And for the topic of where the data resides, so for example, in the second use case, this business technology platform also has a database layer where the customer has all their data stored. But we can also access that locally. So when we are trying to train the model, then we can do that locally or from our server, access the data from there, and then later on in productions, it's just directly used in this cloud platform.
And then there seems to be an interest in how you monitor your services and the deployed models.
Yeah, I can start. So again, for this business technology platform, there are already provided services that you can use to monitor your model. And in addition to that, at least for the evaluation of the model itself, I was just training them locally on the server, and there we had also some just metrics there. So there was no automatic retraining that we had to monitor specifically. I don't know if you want to.
Yes, so we also had no retraining we had to monitor. On Cloud Foundry we used the built-in Grafana stack, so it comes automatically with the Grafana stack that monitors all your applications. On Azure, we actually implemented additional endpoints and then also included them into our own Grafana dashboard. So it comes additionally on top, and this is why also on this slide, monitoring security is also a factor that you can look at when you think about your deployment options, because some of the deployment options come already with a little bit more support in regards to monitoring, for example.
Okay, then the next upmosted question is, how large was the ONX version of your application?
Mm-hmm. So I think after converting the model to ONNX, it was like 400 megabytes large. Yeah. But we just converted the model itself and not the rest of the pipeline. So for that, we still needed the dependencies. Yeah.
And there seems to be a general interest in ONX-related questions here. Did you have to do a lot of ONX coding, or did it come out of the box for the Hugging Face transformer?
Yeah, for Hugging Face, it comes out of the box. Or in our case, we actually use the TensorFlow to ONNX package to do the conversion. But I didn't write any of ONNX converters myself or so. I was listening to them in the talk on Monday, and I'm now very interested in them and want to try them. But we didn't have to do anything that came out of the box.
Oh, wow, that's convenient.
Yeah, maybe just to add, so if you are interested in this ONNX conversions, I found very good tutorials on Hugging Face that explain everything that you have to do there. So you can have a look yourself there.
And I think we have time for one last question. Do you have any requirements regarding latency or throughput? And if so, how did you make sure you can fulfill them?
Yeah, so I think it's also, maybe it's also there in the list. So yeah, we had some requirements about that. We also needed to experiment a little bit with the size of workers we can start in our runtime. So this is where we could handle some of these requirements. So I think it's a little bit easier to do this on the Azure side because you have more freedom about scalability there. I don't know what.
Yeah.
What's your opinion about
so for the second use case, we didn't have any requirements, but I know that on Cloud Foundry it's quite easy to scale horizontally. So just start several instances of your application, and the load balancing will be done automatically. And then for the vertical scaling of instances, you can only do that by redeploying them, and then you have also these limitations of 8 gigabytes of memory. So that's not really the option, but horizontally is fine. Yeah.
Thank you so much. I have 3 more open questions, but I guess you will be hanging around for a moment so people can approach you?
Yeah, for sure.
Then thanks once more.
Thank you.